So in this video, we're going to talk about quadratic inequalities by hand. And what I mean by hand is not using graphing techniques, just doing it on paper, if you will. And so to really understand what we're going to do and why, we are going to look at graphs, but we will not use graphs to solve this one. So the key points in this come from these points of intersection. So if I go back up to here, we put a lot of emphasis on those zeros, because those zeros are where you go from being above a certain point to below, greater than 0 to less than 0. And so we have an explicit focus on the zeros of this inequality, of this parabola right here. And so because that is our focus, we're going to start by finding those zeros. So if I were to factor this to find the zeros, I need two numbers that multiply to be negative 12 and add together to be negative 4. So I have x minus 6 and x plus 2. This parabola has zeros at negative 6 and positive 2. Those are my key points. And so what I'm drawing here is a number line. Now, there are three regions in this. I have critical values at positive 6 and negative 2, because if we set each of those equal to 0, we'll see that x equals positive 6 and x equals negative 2. So our zeros, our critical values, are at 6 and negative 2. Now I know that sometimes we're above and sometimes we're below, but from what I know about parabolas, I know that it changes. It'll change from being from above to below or below to above at those values. I also know that one of two things is going to be true. Either it's going to be above on the outside values, or it's going to be above on the inside values, depending on if that parabola is concave up or concave down. So one way we check this is identify the critical values, identify those zeros, and then simply do a test point. And by a test point, I mean this. Check a value in each range. This goes all the way to negative infinity. This goes all the way to positive infinity. And so I have this range of values between negative infinity to negative 2, this range of values between negative 2 and 6, and this range of values between 6 and infinity. And so we are looking for values that are specifically less than 0. So we pick test points in these three areas, these three, what's the right word, sectioned off, partitioned pieces, and we're going to look for ones that have value less than 0. So if I were to pick a point in each one, say maybe negative 3 over here, 0 here, and maybe, 8 right there. Those are numbers that are in those particular partitioned areas. It's going to tell me if that number there is greater than 0 or less than 0, depending on where we pick it. So I'm going to find f of negative 3, f of 0, and f of 8. Now, f of negative 3 is negative 3 squared minus 4 times negative 3 minus 12. And negative 3 squared is 9. Negative 4 times negative 3 is positive 12. And then minus 12. So that's going to come out to be positive 9, which is positive. So this area over here has values that are positive. When I plug in 0, so that is going to be 0 squared minus 4 times 0 minus 12. Well, 0, 0, negative 12 is negative 12. That is a negative value. So this right here, these have negative values in here. And lastly, f of 8 gives me 8 squared minus 4 times 8 minus 12. So 64 minus 32 minus 12 gives me positive 20. Those are positive values. So if we think about this, this is what we would guess it would be. It is a parabola that has zeros that is a region here that is less than, and has regions out here that are greater than. So when we look at this, what is the solution? The solution where this parabola is less than or equal to 0 is all the values between -2 and 6. I have a bracket on both sides because this is less than or equal to. So in this example, how did we figure this out? One, we found the critical values. The critical values, those places where it goes from being above to below, the zeros. And then we simply picked a test point in each region, and each region allows us to see, is it positive or negative? Now in this case, we're looking for less than 0, so we're looking for negative values, which is why this has to be the right region. It has to be between -2 and 6. Now, continuing by hand, I want us to look at a problem a little more sophisticated. So we have 2x squared. Let me change to black. I don't know why I like black pen better, but I do. We have 2x squared is less than x plus 10. So this is a parabola. This right here is a parabola, and this right here is a line. We want to know, when is the parabola less than, for what x values is the parabola less than or lower on the graph than the line x plus 10? Now, graphically, this is pretty intuitive. When you do it by hand, we actually change this around a little bit. Here's what I mean. We're actually going to move everything to the same side of the inequality. And when I subtract over the x and I subtract over the 10, I get 2x squared minus x minus 10 is less than 0. I literally subtracted away everything on this side. This problem is mathematically equivalent to this problem. They're the same thing. Now, graphically, what we're saying is we basically, when we move it all to the same side, we are shifting this parabola down so that the zeros, or that the points of intersection effectively become the zeros of this new parabola. So when we move it all to the same side, it is shifting the parabola in such a way that the zeros of this new parabola, 2x squared minus 10x minus 10, those are equivalent to, the points of intersection are equivalent to the zeros of this. So if it is equivalent, then all we need to do is actually just solve this, find its critical values of this new parabola. And so if we go to factor this, I have 2x index, and let's see here, I need numbers that are going to give me, let's see, so I need x plus 2, there we go, I think that'll do it. I think it's x plus 2 and then 2x minus 5. Yeah, that checks out. Is less than 0. So these critical values, if I set each of these equal to 0, these critical values, the points where this goes from being above 0 to below 0. Let's see here, I got 5 plus 5 plus 5, and then I got 2x equals 5 divided by 2, and I get x equals 5 halves. This one's much easier, and I get x equals -2. So my two critical values are -2 and 5 halves. Now, if I put this on a number line and think about where these different values are, 5 halves over here, and -2 is going to be back over here somewhere. I've chopped this up, I've partitioned this off into areas that we know are going to be above or below the x-axis. And so once we've done this, we're going to pick a test point. And by the way, 0 is always a really fantastic test point if you can pick it. And I'll throw -3 there. 5 halves is 2.5, so I'll pick +3. I'm going to test out these three values to see where this is less than 0. So this says less than 0. So we're looking for one that is less than 0, one that has a negative outcome when I check these test points. So I'm going to find f of -3, f of 0, and f of +3. The numbers you pick are arbitrary so long as they fall in the particular region that you're testing. So let's see here. I got 2 times -3 squared minus -3 minus 10. So I would highly encourage you to substitute in parentheses with this many negative numbers. It's very easy to make mistakes. Please substitute in parentheses. All right, let's see here, and then 2 times 3 squared minus 3 minus 10. So negative 3 squared is 9, 2 times 9 is 18. That becomes plus 3 with a double sign. So 18 plus 3 is 21, minus 10 is 11. 11, that is positive. So this over here is positive. All right, 0. 0 minus 10 is negative 10. That is a negative value. And 3 squared is 9. 2 times 9 is 18. Minus 3 minus 10 is 5. But that is positive. So I know that the values that are negative, this asks for negative. So the values that are negative are going to be in this middle range right here. So that's going to be from, I started doing brackets, but I got to pay attention to the fact that this is open right here. This is open. So it's going to be parentheses negative 2 all the way to 5/2. So there's a variety of problems. Pay attention to, are we looking for things greater than or things less than? If I had changed this problem ever so slightly and said 2x squared minus x minus 10 is greater than 0, if I had changed it from less than to greater than, the only bit of my work that would change is that instead of looking for the negative values, we'd be looking for the positive values. So this problem right here, we'll call this problem B, because the original one we'll call problem A. Problem B, if we change it to be greater than, the only thing that would change is the answer. All the work would be completely identical, but now we'd be looking for negative infinity all the way to negative 2, union with 5/2 all the way to positive infinity. We would be paying explicit attention to these portions out here. These are the portions that gave us positive answers, greater than 0. That's where our answer would be.